Hi students, today we were going to discuss IoT protocol. So Internet of Things, in previous video we have already discussed the what is IoT, Internet of Things and characteristics of IoT, right? So the Internet of Things devices are trying to transfer their data from the small electronic and IoT device towards the internet. So here we have to follow few protocols to execute and to transfer the data or the information from one system towards the internet and again towards the some client or some user, right? So yeah, you can see here in IoT protocols we have four different layers. So out of this, the link layer, which is very basic layer, a base layer, what we can say, right? So in link layer, again, we were going with a few different, five different protocols we have. Out of this, to execute the link layer, we can follow any one of these protocols. Like you can see here, Ethernet layer, Wi-Fi layer, Ethernet protocol, Wi-Fi, WiMAX, and all. Next, network layer. So network layer is all about we are trying to use some particular ID, right? So that was like IPv4, IPv6, and six low power personal area network. And next one, transport layer. In transport layer, usually we have two different protocols, TCP and UDP. And next, the last layer is the application layer, where a user tries to retrieve the information from the internet, right? So this is what the application layer. Again, we have seven different protocols in application layer. So to understand more clearly about IoT protocol and what are these layers are trying to execute and what part of their uh, area in this IoT devices that we'll be trying to discuss first, and then we'll be trying to know about like what are these layers and each layer what is the protocols we have, right? So to know about that particular protocol, let us go through this small IoT project example. Here you can see, guys, to understand IoT protocols, I have taken a small biometric project. So if you can observe here, here we have a fingerprint module. So in this fingerprint module, we'll be trying to give the authentication. It means like we'll be trying to give the biometric. So with the help of this biometric, the microcontroller tries to get some ID of your number. Let me say I'm giving the attendance in my office. So I'll be giving the biometric. So usually for my biometric, the ID will be registered. That ID number will be taken by the microcontroller, and this microcontroller tries to give to the IoT module a small. Here I have taken ESP8266 in my project. So using this IoT 8266, ESP8266, I will be trying to connect. I will be trying to transfer the data of my ID number into the server, right? I can take any particular web servers, and with the help of that, I'll be trying to transfer my data. And again, if the person who is in the administration who is trying to check out my attendance, he'll be trying to use some laptop or mobile or anything, and with the help of that, he'll be trying to check the attendance of mine. So here, what are the IoT protocols and where it is trying to execute? So guys, if you can observe this, so this is total IoT device. Let us discuss that. This is a biometric system, IoT based biometric system. This is total one particular device, right? An IoT device. And using this IoT device, I'll be trying to transfer my data into the server. From there, it may be used by the application. Some particular application, with the help of application, the user can see the information. So now, if this IoT module has to send some data to the internet, so what it has to use? It should be this, the device should be connected to the internet, right? So what are the possibilities to get connected to the internet? So let me say, if I have my mobile or my laptop or my computer, So what is the source to connect to the internet? One thing, I have to use the LAN, Ethernet wire, right? So Ethernet wire I have to use. With the help of that Ethernet wire, I can connect to the internet. The second chance what I have, I can connect to the internet with the help of Wi-Fi, right? Wireless fidelity. So with the help of Wi-Fi, I can connect. Or if it is a mobile, I'll be connecting with the help of data. So I'll be switching on the data of the mobile of that particular connection. It may be an Airtel, BSNL, or anything. So Geo. So I can connect the data and I can connect to the internet. So that is what we call it as a link layer. So to connect to the this IoT device to get connected to the internet, that is what we'll be calling it as a link layer. So these are all the protocols, right? So Wi-Fi, Ethernet, and all. So next, so that is what one layer. Next, another layer is all about uh, the network layer, right? So yeah, you can see here network layer. So let me say, guys. So for each and every particular IoT device, it should have some particular ID number, right? It should go with some particular number or some particular unique internet protocol number, what we can say. Generally, you may have listened 192.168.100.10, so like that. That is what IPv4 we call. So now as the IoT devices are increasing day by day, we were dealing with the IPv6, right? So it has like six digits. Like here you have 192, 168, 100.100. So as we have version 4, we have four digits, four different numbers, dot dot. So like that we'll be having six numbers. So that is what the ID of one particular device, right? So you may see some particular um, websites. It may be a Flipkart, it may be an Amazon, or it may be some sort of math work. So each one have its own ID number. Instead of try typing that amazon.com, you can have the ID number and you can try to get connect, right? So this is about the internet network protocol, right? So next what we have is about transport protocol. So transport protocol is all about how this total data is trying to transfer to the server, from the server to the user. So we should follow some particular protocol. So here we have two different protocols, TCP and UDP. So using TCP or UDP, you will be trying to take the data and you should follow some particular protocol and you will be trying to take to the server, right? That is what transport protocol. Next, what we have is all about, sorry, you can see here after transport application layer protocol. So in application layer is all about the last end of user end. So where the computers, and using computer or laptop or mobile, you are trying to take, or you are trying to check the, you are trying to monitor the data. Whatever the data is transmitted, this IoT device is transmitted to the internet servers, that you are trying to check it with the help of another computer or laptop or some mobile. With the help of that, you will be trying to check what are the data information has transmitted to the internet. So that using some laptop or computer, you will be trying to check. So that is what application layer. So in this application layer, what are the chances of checking out the internet? Yeah, you have one thing is that www dot, you will be trying to type some google.com or Amazon or things. So like that. So that is one type of protocol that we'll be calling it as HTTP, right? HTTP protocol. Like that, we have many. You may see in your mobile, you have the apps, multiple apps. You can check it out. Like WhatsApp is an app. So that is what application. So that is also one type of protocol. So you will be having multiple protocols as you can design different apps. You have the Zoom, which is an YouTube. Your video can be getted visible. Your video and audio also is visible. Audio also is audible. So like that, the different apps are there. Those are all called as application layers. So guys, I feel like using this one particular IoT protocol, IoT device application, I think you have understood like what are these four layers for, and how this individually each layer have different protocols. What is exactly IoT protocol, right? So by this I can say that this is all about the IoT protocol and how we can execute, and each layer is what the major reason and what is the purpose of each layer. Now let us know each layer in brief. So link layer. So link layer is a group of methods or communication protocols confined to link that host is physically connected. So that is what. So your IoT device or a particular system, how it is connected to the internet, right? How it is physically connected to the internet. So that is what about the link layer. So how it is connected, as we can say like the we have different protocols. One of these is Ethernet standard vehicle. So with the help of you may see like you have will be having some LAN wire, we'll be calling in some cases like you have to go with the LAN card. So that is what we'll be calling LAN wire. So that Ethernet wire, with the help of that wire, you'll be getting connected to the internet. And that internet, with the help of that internet, you'll be trying to transfer your data or you'll be trying to get the request. So that is what we call it as an Ethernet standard. So Ethernet standard, actually the IEEE standard, we have international electronic and electrical engineering standards we have. So that standard is trying to give some particular, that organization IEEE organization is trying to give some particular standard numbers such that this particular is recognized. So like that IEEE standard 802.3 is for Ethernet protocol, right? So in this Ethernet protocol, 802.3 is an IEEE organizer standard. So here again in 802.3, we have another few mediums you can see here. In 803.2.3 is a coaxial cable type, or you can have 3.I, which is a twisted pair, or 3.J is a fiber optic, 3.AE is also an fiber optic with 10 gigabytes per second. So as the wire, totally finally I can say that is a wired protocol, wired connected internet service. So here in these wires we have again types. Generally you may observe like a round color cable, coaxial cable. So again there may be a fiber like people, I think right now in BSNL connections they are using fiber optics, whereas in some offices or some in our houses in some cases, like if you are following local one, they are using coaxial cables or twisted pair cables. So like that, as the different organizations are using different cables, but all comes under Ethernet protocol, right? So next we have the other two protocols are Wi-Fi and WiMAX. So Wi-Fi, you also know like wireless fidelity, with the help of some particular router and with the help of some particular operating frequency, you'll be trying to get connected with the multiple gadgets. This Wi-Fi. So even Wi-Fi has given some standard by the IEEE organization, which is called 802.11. 802.11 is an standard for Wi-Fi communication and Wi-Fi protocol. So here again in 802.11 we have A, B, G, N, AC and AD. So this was differentiated with the help of bands. As you are changing the band of frequencies like 5 gigahertz, 2.4 gigahertz, 2.4 to 560 gigahertz of band. So as the differentiation of the bands depending upon the routers and depending upon the multiple users following the Wi-Fi, the band will be changed, frequency bands will be operation, frequency band will be changed. As the change going on, the standard extension will be there like 802.11a, 11b, 11g and like that. So anyway, this is about the Wi-Fi. The now next down one you can see WiMAX. So WiMAX is also one of the protocol where you can get connected to the internet. So that protocol standard is at not 2.16, right? So this is also the data rate. You can see 100 Mbps per second for mobile stations, and for if it is a fixed station, it is all about 1 gigabits per second. Right, guys, you can observe here the other two protocols in link layer, which is LRWPN. We'll be calling it as low rate wireless personal area network. So this mostly this is not to get it connected to the internet service, but yeah, with the help of a small area, you can get connected to one particular network, right? It's a low area network. And next one, you usually most of you are usually using, that is what, the mobile data, right? 3G, 4G. So this is also one of the link layer protocol, right? Mobile data communication, right? So this is about the link layer, guys. Next, coming to the network or internet layer. So in network or internet layer, this is what the responsible for sending the IP datagram for the source to destination, right? So IP will be calling it as an internet protocol. So this IP internet protocol is an performing some host addressing. It's an, we'll be calling it as an host address, right? So that it is an packet routing event. And host identification is done with the help of this hierarchical IP, right? So these schemes we have IPv6 and IPv4. So generally, in olden days, most of us used IPv4. Now, as the advancement came, the more number of IoT devices increased. So IPv6 came into the existence. You can see for identification number of internet protocol IP is used. Usually in IPv4 we have using 32-bit address scheme, and in IPv6 we are going to use 128-bit address scheme, right? So these are the two major protocols used for the internet purpose to get connected to the internet. We have the another one which is LIX6, low low power wireless personal area network, which is all about, like as I said, lower range, means within a small network which is not connected to the internet actually. So this is all about, like, which is a small area capacity, limited processing, and which is operating with 2.4 gigahertz and data rate is 250 kilobytes. So this is about the internet protocol, internet or network protocol, what we call. Next, transport layer. So usually I said this transport layer is helping us to transfer our data from source towards the destination or the internet. So this is a providing end-to-end message transfer. It is capable of independent of underlaying the network, and it provides the functions such as error control, segmentation, flow control, and congest control. So these are the features of transport layer. So usually we have two types, TCP and UDP, transfer control protocol and user defined protocol. So these are the two different protocols, whereas transport we usually use for internet services, high end global services, we use TCP, and in only few cases in lower area ranges we'll be using UDP. So yeah, this is what transmission, TCP, transmission control protocol. Sorry, I said transfer, sorry, it's a transmission control protocol. This TCP is totally connection oriented. It's a reliable transmission, and it provides error detection even. It is an ensuring the duplicate packets and retransmitting. If it is not received perfectly, we'll be trying to retransmit. And it's a flow control capability. It has an it has the capacity of controlling the flow even. And it will be cross checking everything. It will be checking for the acknowledgement, and this is the best protocol, best transport protocol to use actually. So why we were not going with the UDP, we'll be checking here in the user, in UDP it is a user datagram protocol, where it is a connectionless actually, and it is not at all reliable, and it is not connection. It not do connection before transmitting. It is not going to check, and it is not acknowledging each other, and it is an transaction oriented and stateless connection. So this is the major reasons. Mostly these UDPs are used for the smaller areas, not for the higher global area network connection. Only in office purpose within a local areas we'll be using, but in most areas we'll be using TCP protocol. Next, application layer. Yes, guys, in application layer, actually, as compared to the other layers, we have multiple protocols. But one of the best protocol in the application layer is all about like the final end, the user checking the IoT data with the help of some particular application. Actually, the IoT data is transmitted to the internet. So this user is trying to check the whatever the data transmitted to the internet or the servers, that you will be calling and you will be checking out whatever the data is transmitted. That IoT device is transmitted to the server internet, right? So that data is checking by the user with the help of some particular application. So what are the types? So generally, let me take one particular Flipkart or Amazon, some shopping malls, shopping web, online shoppings. They try to add the products generally. So they'll be trying to add new products to be buy. So those are all added into the Flipkart or Amazon. So what we do, we generally try to type amazon.com or flipkart.com. So there you will be trying to know the what are the products are there, right? So this is all about request response. So this is what HTTP protocol, or we'll be calling it as hyper transfer protocol, right? So this hyper transfer protocol is all about using the foundation of World Wide Web, www. So like this, we have multiple. So generally, those are trying to use some particular server, the Flipkart. They are not IoT devices actually, but thing is all about they are with the help of computer only. They are using some server web page, and there you will be they'll be trying to execute. So generally, I used to have for my IoT devices in my project, I used to have ThinkSpeak website. So ThinkSpeak is one type of server where my IoT devices, as I shown you in the beginning, one biometric project. So I used to send total data in ThinkSpeak website. So in the ThinkSpeak website, you can check out the data. So I will be trying to type www.thinkspeak.com, and there I will be checking what are the IDs, what are the data I have transferred there. So like this, HTTP protocol, like hyper transfer protocol is used. Like we have few more protocols like that. COAP, constrained application protocol. So generally this constrained application protocol is used for machine to machine application purpose. So this machine to machine is all about like both should be machines. Like there surely that is a machine IoT device. From the IoT device you will be getting to the server. From there, with the help of some particular COAP application, constraint application, automatically you will be trying to retrieve the information, right? So, so this is what here also we'll be trying to use the request response model client server architecture. And of course, whereas this methods here you can see get, post, put, and delete. We have only four methods, whereas in HTTP in previous protocol you can see get, put, post, head, means you have more commands to be executed in WW. So here you are going to decrease the commands over here, right? Next, WebSocket, MQTT, and XMP. So these are the different applications. Like WebSocket is all about like communication over a single socket. Like I can say an app like WhatsApp, right? So the app like WhatsApp, they'll be going to get some sort of messages. So they'll be trying to change. So with the help of IoT device, I'll be trying to send the messages to the particular application, right? So this is like the WebSocket. Next, other MQTT, message queue telemetry transport protocol. So this MQTT is all about like lightweight messaging. So usually this is also like publish subscribes, like everything. If the IoT device trying to transmit some any data, automatically that will be seen in our application, like whatever the data, like if it is a medical purpose IoT device or something purpose, even the biometric. So every data automatically instead of opening the application and checking and requesting, here in MQTT, automatically the data will be as usually the server gets the data, the server tries to transmit the data to the application. That is what MQTT. Next one, XMPP, which is Extensible Messaging and Presence Protocol. Here is all about like you are trying to use some sort of video and voice calls. So most probably we'll be trying to use such a protocols in robotics or like in drones where you can see the cameras, you can have the cameras over there, you can have the mic over there, so you can see the video and you can see listen the voice even. So like that, this is a high-end protocol, we can say XMP, right? Extensible Message and Presence Protocol. So these are the IoT protocols, guys. As you have, as I said, like we have four layers: application link layer, network layer, transport layer, and application layer, right? So the link layer is all about like you are going to have get connected to the internet, maybe like with the help of Wi-Fi or with the help of mobile data or Ethernet, and network layer is all about like getting having some particular ID like IPv4 or IPv6, some identification number towards your device. And next is all about transport layer. You will be trying to use TCP or UDP protocols. And the last one, application layer, is all about the end user end, how you'll be trying to retrieve the information, either using some web page or either using some application, some different in even in applications we have different types of applications, right? So this is about the IoT protocol, right? Thank you. Yeah, if you have any doubts you can give it in chat box so that I can reply.